Question 5 and the mark scheme can be bullet pointed into 11 tasks. They are 1. Import of the maths library. 2. Two parameters in the first line of the subprogram definition with the names p-radius and p-height in any order. 3. Accurate translation of the formula into code. 4. Use of the pi constant from the maths library in the formula translation. 5. The two parameters that have been passed in, p-radius and p-height, are used in the calculation. 6. Assignment of the result of the calculation to the variable the volume. 7. One return statement returning the variable the volume. 8. The two parameters used in the subprogram call are base radius and cone height. These can be in any order. But be aware for bullet point 9, the order of parameters must match the order used in the first line of the subprogram definition. 10. The value returned by the subprogram must be captured by the variable cone volume. And 11. The outputted variable cone volume must be formatted to 3 decimal places. Question 5 also has the functionality level based mark scheme. This is the original question from the GCSE 2020 Computer Science Specimen Assessment material. This question is set in the context of a science investigation. An arithmetic formula is given with each variable defined. The question indicates that there is existing code. The amended code must meet each of the requirements in the bulleted list. By amending the code to meet these requirements, students will achieve a maximum of 15 marks. This is the file that the students are given during the exam. When students are given a data structure or partially complete code, they should use what is provided and not change it. In this question, which involves a formula for the volume of a cone, it is not important that the student actually understand the formula. The marks are for accurate translation of the formula into program code. By providing a working algorithm that has had some of the required code removed, this question provides a high level of scaffolding. In summary, the marks for response A were awarded as follows. 1 mark for correctly importing maths library on line 6. 2 marks for both parameters with the correct names in the subprogram definition on line 20. 1 mark for correct translation of formula on line 27. 1 mark for the use of math.pi on line 27, which they have used by assigning math.pi to a variable on line 21, and then use this variable on line 27. 1 mark for the subprogram input parameters used in the calculation on line 27. 1 mark for assignment of the calculation to the variable the volume on line 27. 1 mark for returning the correct value on line 32. Although the mark scheme calls for the use of brackets here, omitting them will not change the functionality of the algorithm, and so the mark has been awarded. 1 mark for the order of arguments on line 40, matching the order of the parameters of the subprogram definition on line 20. 1 mark for capturing the returned value in cone volume on line 40. 1 mark for correctly formatting the output on line 44. 3 marks for a fully functional program that meets all the given requirements. The total mark awarded is 15. You or your students may wish to annotate onto this example those accredited points, and then look at how they might improve them to score a higher mark. Although in this case, there is a maximum number of marks have been awarded for this solution. For response B, marks were awarded as follows. 0 marks for importing math library, as it hasn't been done. 1 mark for the right number of parameters on subprogram definition, but no mark for using the correct variable names. 1 mark for accurate translation of the formula, even though an approximation of pi is used on line 25. 0 marks for using maths.pi as an approximation was used on line 25. 1 mark for using the input parameters from line 20 in the calculation on line 25. 1 mark for storing the calculation result in the volume on line 25. 1 mark for returning the correct value on line 30. 1 mark for passing in the correct arguments to the subprogram call on line 38. 1 mark for matching the order of the arguments on line 38 to the parameters on line 20. 1 mark for capturing the return value into the variable volume of cone on line 38. 0 marks for formatting the output to 3 decimal places, line 42. 2 marks for functionality as the response translates, runs, and meets some of the requirements. The calculation is accurate, and some of the required outputs are displayed. The total mark awarded is 10. For response C, marks were awarded as follows. 1 mark for importing the math library on line 3. 0 marks for the correct naming of the parameters. Note, the student has commented out lines 12 and 13, which are required to demonstrate understanding of locally named parameters. 1 mark for correctly translating the formula on line 16, and 1 mark for using math.pi constant on line 16. 0 marks for using the input parameters in the calculation, especially as lines 12 and 13 are commented out. 1 mark for the assignment of the calculation output to the variable the volume on line 16. 1 mark for the return statement on line 21. 1 mark for using the correct arguments in the subprogram call on line 25. 1 mark for the order of arguments in the subprogram call matching the subprogram definition on line 25. 0 marks for catching return value in cone volume. 0 marks for formatting the volume to 3 decimal places. 1 mark for functionality as the response translates and runs. The volume calculation is done correctly. The total marks are 8. In a question like this where there is a formula, it is not necessary for students to understand the formula. They only need to translate it accurately using order of precedence arithmetic operators or using fully bracketed statements. Lastly, for response D, marks were awarded as follows. 1 mark for importing the maths library on line 3. On line 11, 0 marks were awarded for the input parameters as this was not attempted. 0 marks for using correct variables in the calculation on line 17 as R and H are used. 1 mark for using math.pi in the calculation on line 17. 0 marks for using parameters in the calculation as it uses R and H on line 17. 0 marks for using the correct variable to catch the result of the calculation on line 17. 0 marks for the return statement as it does not return the correct variable on line 21. 0 marks for passing the correct calling arguments as this was not attempted on line 26. 0 marks for the order of the passed arguments matching parameters as this was not attempted on line 26. 1 mark for formatting cone volume to 3 decimal places on line 29. 1 mark for functionality as some lines translate and execute. The decompositions do not, so marks must be limited. The output is printed to requirements even though the value is incorrect. The total marks are 4. Again, review the mark explanation document for additional explanation, including how this candidate could have improved their response. You might want to consider how different this response was to the first, and again, how you might improve this response to achieve higher marks. Any open-ended scenario is suitable for this type of question. However, the exam time constraints need to be considered. Students should be able to complete the task in 25 minutes. In this particular problem, it isn't important that students actually understand the formula for calculating the volume of a cone. All that matters is that the formula can be read as an arithmetic expression and can be translated to Python. This type of question is easiest developed from a working solution. That is, write the solution before the question. Choose a problem that can be decomposed into one or more subprograms, procedures or functions. Write the solution yourself, following the conventions from the programming language subset and using distinct names to differentiate the parameters, local variables, and global variables. Decide which parts of the solution will make up the mark scheme. Add scaffolding instructions to guide the student through the construction of the solution. Then remove the parts required in the response. This particular question uses a functionality levels-based mark scheme. This provides an opportunity for students to demonstrate that they can amend code to generate functional, or at least partially functional, solutions. When allocating items to the points-based mark of the mark scheme, it is important to consider how much of the solution is functional, rather than which parts. Student A could be awarded a mark for part A, while student B could be awarded a mark for part B. You can use this flowchart as a step-by-step to both support the creation of this question type and also the decision-making behind creating an accessible and challenging question for your students to complete.